Katrina here, and today we're going to dive into probability and statistics, and we're going to chat about random variables. Make sure that you're watching to the end so that you can see the step-by-step example that we're going to do today, and please subscribe so you can see more videos. Okay, let's dive in. So let's look at the definition of a random variable. So a random variable, contrary to what its title is actually a function. And it's a function that maps an outcome from a sample space S to the real line, so to R. And it is denoted mathematically as our big variable x, so large X, and it maps outcomes from our sample space S all the way to our outcome space, which we're going to define as R. So again, it takes something from our sample space, maps it onto our target space or to the real line. So now you know it's a little bit of a contradiction. It's not simply just a variable, but it is actually a function that takes all these random outcomes from an experiment and maps it onto some real line or our target space. So let's actually look at an example so we can clear up what this means, and we can see how it works in our world. So let's do the typical example where we have a coin toss. So we're going to deal with a fair coin. So we have two options. We can either get heads, which we will denote as H, or we can get tails, which we will denote as T. So there's two possible outcomes when we have one coin toss. So if we're having these two outcomes, just so you know, this is called a fair coin, in case you see that wording anywhere else in your textbook. So what we're going to do in this example is we're going to record the sequence of heads and tails in two tosses. So we're going to do two tosses in a row, and we're going to see what is our sequence of heads and tails. So what is our sample space from this random experiment? So we see that our sample space is, we're going to first denote it as capital S. So we have our big S here, which is our sample space, and we see from our experiment that we end up with two heads in our first two tosses. Then we have a heads, then tails. Then we have tails, then heads. And on our last two tosses, we get two tails. So now we have this sample space that we have created from our random experiment. So suppose now that we are only interested in heads. So we only care about heads and we want to track that result. So that means that we are defining our random variable x that tracks the number of heads obtained in an outcome. So x, we're going to have that denoted as a random variable, and it's tracking the number of heads. Okay, so that's how we're setting up this experiment, and now you'll see how we can take these values that we have over here from our sample space and represent them mathematically. That's the whole trick of having our random variable. Okay, so that being said, if we were to just look at our sample space here quick, and we look at our first instance, we see that we have two heads in a row. So that means that x would equal to 2 in this case. So since there's only 4 outcomes in our sample space S, we can list the values of x for each of these outcomes individually. So let's start and do that. So let's recall our formula. So we know that our x is mapping everything from our sample space to the real line, and in this case we're going from our sample space to the number of h's in S. So this part over here, the number of h's, this is going to be a real number. Like we saw, it could be 2, it could be 1, or it could be 0. So let's do it for our function in particular and see what we get. So we've got our inputs over here. So we'll write that out. So we got our inputs, which is in our sample space. And then we have our function. So this is our function, our random variable x. That again is mapping from our sample space to the real line. And then on our right hand side we have our outputs, which is going to be the real numbers. So let's go for each element in the sample space. So the first one we have is 2 heads being tossed in a row. If we go through our function, we see that our output is 2 because we are tracking the number of heads, remember? And our second one is heads first, then tails. So that means that we only have 1 head. If our third one is tails, then heads, this is also just 1 heads, right? And then our last one here is tails, tails. So this maps to the number 0 because we have 0 heads in that case. So we can also use an alternative notation and write it as follows. So we can use this kind of, I would say, like more function notation here. So we could have, let's write this out, x of hh equals to 2, x of ht equals to 1, x of th equals to 1, and x of tt equals to 0. So this should be familiar with you in terms of like function notation, and a lot of probability just builds upon this. So the advantage to defining a random variable x in this context is that these two outcomes over here, our ht and th, are both assigned a value of 1. So this means that we're not focused on the actual sequence of heads and tails, but rather we're just looking at the end result. We want to know what is the result of just obtaining 1. So that's a really neat example that it takes something very basic such as flipping a coin, but we can see how we can take that abstract concept of a real life activity and how we can use a random variable, and now we can make it something concrete. We can make it into a real number. So let's continue our discussion about random variables, and I'm going to show you that there's actually 2 types of random variables we can have. The first type is called a discrete random variable. So in our above example, those were discrete random variables. When we have a coin toss, we can either get heads or we can get tails. There's 2 possible outcomes from one coin toss, and you can't get any value in between. You can't get half of a head or half of a tail or 3/4 of a head. You can either get heads or tails on a given toss. So a discrete random variable has either a finite or countably infinite number of possible values. So we're defined. So we can only be finite or countably infinite. So we can't have an infinite number of possibilities. So let's look at some examples that would be this case. So here we see the coin as an example. We can say the number of kids in a class would be like another example. The number of plants in your house. These are all things that you can count. And these ones you can also think of as more mathematically. They can be integers. They can be our natural numbers, our whole numbers. So we can count these numbers. Whereas the second type of random variable is a continuous random variable. So this means that there is an infinite number of possible values that we can have. So for this one, think of the real line. Think of all the real numbers. Even consider an interval from 0 to 1. On this interval, we take the number 0, we take the number 1, And there's actually an infinite amount of numbers between 0 and 1. Imagine you can have 0.002, 0.075, and it goes on and on and on. Whereas in a discrete situation, there would be two outcomes, either the outcome 0 or the outcome 1, and nothing in between. So some common examples of continuous random variables, for example, might be one's height or one's weight, because there's an infinite amount of possibilities of both of these measurements. So I hope this gave you a pretty good understanding of what a random variable is, and an understanding that it is a function that takes these random experiments, which are classified then in a sample space, and maps them into our target space, which is a real number. So how can you take something abstract such as a coin toss and represent this mathematically? This allows us to look at the properties of so many functions and aspects of probability, and allows us to come to various conclusions, and allows us to use mathematical manipulations. So stay tuned for my next videos, where I'm going to be showing more about how we use random variables in probability distributions. If you enjoy this video, please drop a like and subscribe for more fun and easy to follow math videos. Any questions that you have, drop them in the comments and I'll get back to you as soon as possible, and I look forward to seeing you next time.